Welcome to my channel. Here I'm going to explain to you how you can construct a square equal in area to a given parallelogram. How to construct a square equal in area to a given parallelogram. So, and what we are going to do first is to construct the parallelogram. I'll give you dimensions as I go on constructing the parallelogram. So let's start. So for the parallelogram, so we are going to draw a horizontal line here. So then I'm going to take a measurement of 70 millimeters. 70 millimeters. So distance from here to here is 70 millimeters. So I'll call this point. This is point A, and this is point B for the parallelogram. Okay. Then I'm going to use my 60-degree set square to draw an angle at this point. So that is a line at this point. So a line at this point. So draw a line at this point. So this line is at angle 60 degree to this horizontal because I use 60-degree side of my set square to do that. So also I will draw a line at this point. So the line at this point that will also be at an angle 60 degree to the horizontal. Okay, so we've done that. So now, let's take the height of the parallelogram. Let's take the height of the parallelogram. In this case, let me use the side. So let me use the side. So let's take a measurement of 30 millimeters. 30 millimeters. So from here, this is 30 millimeters. That is this side. And this side also will be 30 millimeters. So let's take 30 millimeters on this line. This is also 30 millimeters. So this is point C here. So here is point C and here is point D. So this is point D. Okay. So we have parallelogram A, B, C, D. So I need to connect C, D together to complete the parallelogram. So to complete the given parallelogram. Okay, so you can see the way I constructed the parallelogram here right now. So it's as simple as we have done it here. So I want to make this sides of the given parallelogram to be more feasible. That's what we're trying to do. Okay, so don't forget that we are constructing a triangle that is equal in area to this given parallelogram. Alright, so we are done now. So the next thing that we are going to do, is that I will take my compass. Okay, so I will take my compass. So before I take my compass, I'm going to erect a vertical line at this point or a perpendicular line at this point B. So this is what I'm going to do. So I will erect a perpendicular line or vertical line at this point B here. So we draw a perpendicular line like this. So this line, let me call it line A. So line A. B. Sorry, it is B. So vertical line or perpendicular line BE. So it's at a right angle to this horizontal line AB. So let's take note of that. So the next thing that I'm going to do is that I'll take my compass and put the midpoint at B. Okay, put the midpoint at B, and then this point here, where the perpendicular line meets this line CD. So I will call it point F. So I call it point F. Now I put the midpoint of my compass at point B here and extend it to point F. And extend to point F here. So at B. So I'll extend it to point F. Then I'm going to draw an arc. So I'll draw an arc from this point. So from this point to meet this horizontal line, AB produced or extended like this. So this point I'll call it point G. So this is point G. Okay. So now, the next thing that I'm going to do is that I'm going to bisect distance AG because I'm going to construct a semicircle on this line. So I bisect distance AG. So that is what I'm going to do. So let's do that. So with our compass, so we put a point here and we extend it to any convenient distance. So more than half of AG. So we make an arc up here and also make an arc down here like this. Then putting a pinpoint at point G here. Pinpoint at G. So I make an arc here and then I make an arc like this. Okay. So then we need to locate the midpoint of AG. So to locate the midpoint of AG, that is what we want to do here right now. So if I draw the bisector of distance AG like this, so it means that this point here, this point is the midpoint of AG. So I'll call this point, I'll call it point X. So that is point X. So the next thing that I'm going to do is that since we are constructing a semicircle on point A and G, so I will put a point of my compass at X here, which is the midpoint of AG. So extending it to this point G here, or I will extend it to point A, anyone that I like. Say that I use AG, that I use XG, or I use what? I use AG. So what I'm going to do now, so what I'm going to do now is to draw the semicircle and it goes like this. Okay, so this is semicircle. Okay, so we have the semicircle like this. So this semicircle, as we drew it, so it touches this line BE, touches it at this point. Touches at this point. So this point here now, I will call it point H. So this is point H. So this BH is one of the sides of the square that be equal in area to this parallelogram. So this line BH is a side of the square that will be equal in area to this parallelogram ABCD. So let's go and construct the square now. So what I need to do is to put the midpoint of my compass at B and extend it to point H here. Okay, then I'll make an arc here on this line like this. So this point, so this will be point I. Okay, so then I put a point of my compass at H here, so making an arc here like this. Then with the same radius I put it here and make an arc here. So this will be point J. So this is point J. So what I need to do now is to join. So I will join IG together. Join IG together. For this, then join H and J together. Then I will join EI to make it a thick line. And then BH, I'll make it a thick line. So this is how to construct a square that is equal in area to a given parallelogram. As simple as I've done it here. All you need to do is to practice. When you practice it, you become a master at it. Thank you and God bless you.